All right, so the next kind of factoring is called difference of two squares factoring. And basically, if we go back to FOIL, if we multiply two binomials where they're the same values, right, A and B in both, but one of them has a plus and the other one has a minus, those are called conjugates of one another. So A plus B is a conjugate of A minus B. So when you multiply conjugates, what happens is you get this situation here, right? A times A is A squared. A times negative B is negative AB. B times A is positive AB. And then B times negative B is, and actually I messed up here, is negative B squared, right? Let me see. So that should be negative B squared. All right. And so what happens is those middle two terms, negative AB and positive AB, cancel each other out, right? They're opposites or they're additive inverses, so they cancel each other out. So all we're left with is A squared minus B squared, right? And so that's what happens when you multiply conjugates. And so if we have a situation like this, A squared minus B squared, we can actually factor that to look like this, right? Remember backwards FOIL. And so if we see this going on, we know the pattern that this is what it started with. Okay. So once again, this is a difference of two squares, right? So we have two perfect squares and there's a difference. The signs are different. Okay. And the way we get back to the original is we take the square root of A squared, and that gives us A, right? And then we take the square root of B squared, and that gives us B. And then we just put another A and a B, and we make sure that we have a plus and a minus. All right. So let me show you how that works. Hopefully that made sense. But I think definitely when you see the examples, it'll make even more sense. All right. So here we have x squared minus 100, right? So notice here how b equals 0. We don't have a linear term, right? We don't have a term with a regular x in it. We just have an x squared and a constant. So our quadratic and constant term. All right, but I can see these are both perfect squares, right? X squared is a perfect square and 100 is a perfect square. And we have a difference. So all those three things are checked off. It's a difference of two squares, right? So when you say difference of two squares, those three conditions are in the title, right? It's a difference, there's two, and they're both perfect squares. All right, so what I'm going to do is I'm going to set it up like this. And I'm just going to take the square root of x squared, which is x. So I'm going to put that here and here. Then I'm going to take the square root of 100, which is 10, and I'm going to put that here and here. And then we're just going to put a plus in one and a minus in the other. It doesn't really matter what order. You can do the minus first, then the plus. But here we have two conjugates, right? X plus 10, x minus 10. And that's all it is. Okay, so from here, we know that we can use the zero factor property to say, okay, well, if x plus 10 and x minus 10 equals 0, we can split that up into two. X plus 10 equals 0. X minus 10 equals 0. And we can just subtract 10 from both sides. So we get x equals negative 10. Or we can add 10 to both sides. So we get x equals positive 10. And by the way, I don't mind if you go straight from here to the answer. Okay, if you realize, oh yeah, it's going to be the opposite of this and the opposite of this, then that's perfect, right? You can go straight to the answer on this one. All right, so that's how you do difference of squares. So let's take a look at number 4 now. So this one we have equals 25, right? So we want it to be equal to 0 like we had on the last one. So what I'm going to do is first I'm going to subtract 25 from both sides to get it equal to 0. And you want to do that before you determine what kind of factoring it is, because sometimes it may look like one thing and then when you get it equal to 0, it may turn out to be something different. All right, so now I'm noticing that, okay, b equals 0, right? So this may be a difference of two squares. So let me go do the checklist. Is it a difference? Yes, it is. Signs are different. Are there two terms? Yep, two terms, b equals 0. And so we just have our a and c term. And then are they both perfect squares? 36x squared is a perfect square, and 25 is a perfect square, right? And perfect squares are like, in case you didn't know, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared, 6 squared, 7 squared, right? So these are your list of perfect squares. That was 8 squared, 9 squared is 81. Okay, and you can keep going forever, right? But that's a list of 1 to 100 there. So 36 and 25 are on that list, so they're both perfect squares. So now I can get it to this format. I'm going to take the square root of 36x squared, and that'll give me 6x, right? Square root of 36 is 6. Square root of x squared is x. Then I'm going to take the square root of 25, and that gives me 5. And then we're just going to put a plus and a minus. Okay. And so from here, we can set these equal to 0. All right, and then I'm going to subtract 5 from both sides. And then divide by 6. Okay, now I'm still okay if you want to go from here to the answer, right? So remember, when you have a coefficient, just remember to divide by that coefficient, right? So you still change the sign of this, becomes negative, but then you divide by the coefficient, okay? So let's try this one. So it's going to be positive 5 over 6, right? So this would be x equals positive 5 over 6. So you can go straight from there to the answer if you want. I'll show the work just to make sure everybody's on the same page. And there's always no problem with showing more work, right? So, but if you want to on these, you can go straight from this step. Once you have it in once you have it in factored form, you can go straight to the answer. All right, so this is the difference of 2 square factoring. Hopefully this is a review for you and you remember this, but just remember that when b equals 0 and you have two terms, and one of them's the quadratic term and the other one's the constant term, then a lot of times difference of squares factoring works, right? But they have to be perfect squares and there have to be a difference, right? So if either of these, like if this first one, instead of x squared minus 100 equals 0, if it's x squared plus 100 equals 0, then we wouldn't be able to do difference of 2 squares. So this is not a difference of 2 squares. Okay, so because of the plus there. So don't overgeneralize, right? Make sure it's a difference of 2 squares.